Hello everyone and welcome to the very first hints video for the spring break packet I gave you right before break. Hope that you've been enjoying your break and you've had a chance to work on this one. We're going to be looking in this video at the first 6 problems that in the packet. So let's get started looking at number 1. In problem number 1, now one thing to keep in mind with these hints video, I'm not actually going to do a lot of the work, I'm just going to describe some things that you have to do with them. Might write some stuff down, but a lot of it is just going to be more explanations. The first thing you have to remember, number 1 is a calculator question. And as I explained before, the way this works is when you go to the free response, you're going to get 30 minutes to work on questions 1 and 2. Those are the 2 questions that have where your calculator is allowed. During this time, it's going to be important for you to focus on making sure you get the calculator stuff done, because when you go to the non-calculator part, when you're able to start questions 3, 4, 5, and 6. All you're really doing is putting the calculator away. You can come back to 1 and 2. You just cannot use a calculator anymore. So when I look at question 1, part of what I look for is what do I have to use a calculator for? I'll barely look at both questions 1 and 2, look those over quickly, see what I have to use a calculator for, and then progress from there. Now, in this case, this first one that you have, they want you to use a left-hand sum. The first 2 are related to each other. They want you to use a left-hand sum with the 3 sub-intervals indicated by the data. So remember, with a left-hand sum, you're just using the left-hand endpoint. So in this for this left-hand sum, you also have to recognize that this is not a regular partition. You're going to have the first interval goes from 0 to 2, the second from 2 to 5, and the third from 5 to 10. There are times when they do give you, they ask you to use a midpoint sum. Okay, so what happens in that situation, there is going to be, if you were looking at a midpoint sum, just in this instance, you might be they would give you 0, 2, and then probably a 4 here. And then the second value, this one would be your midpoint, would be considered the midpoint. But this one's a left-hand sum. So we have to go through using these. So 1 from 0 to 2, 2 to 5, and 5 to 10. The other part is that they want you to go through and tell me if it's an overestimate or underestimate. Now, when you do something like this one right here, this one right here is worth 1 point. You get 1 point for the correct answer to overestimate or underestimate, and you have to have your reasoning. So you can't just say, oh, overestimate or oh, underestimate. You have to explain why you think that. And the key thing you have to remember here is really, if they're asking you to do an overestimate or underestimate, you need to be looking at the pattern that's happening with the A of H, or the Y values, if you will. Look at that to give you your determination about what's happening. The next one here, the area in square feet, this one, based on this model, they want you to find the volume of the tank, indicate units of measure. Keep in mind, the units are key in all of these. Okay, so you always have to go and keep that in mind. Remember here, so in this case right here, one of the issues you have to realize what this is telling you. This equation right here is the area of the cross-sectional face in square feet. Remember, when you're going to find a volume, you need to integrate an area formula. Okay, think about that. And then the last one here, water's pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26. They want you to use the model that you have up here to find the rate at which the volume of water is changing with respect to the time at the height there, of the height at 5. So in this case, remember, your volume, you're going to have a volume function up here that will end up being a definite integral. Okay, so you're going to have to use that volume function to work with this. And remember, they want these rates are with respect to time. So when you're working with that volume function up there, remember you're taking the derivative of that thing with respect to time. So keep that in mind. You should be okay with this one. This one right here is would be common to both the AB and the BC, because this is really an AB question. Now let's take a look at question 2. In this question, you have to deal with the fact that you have a function f of theta is this one, r of theta is equal to 2 cosine theta. Now the other aspect of it is they describe the regions here. So region R, this region, is just bounded by f of theta, and region S is the region between these two. So you got to be aware of that one. The first question they ask in this one is to find the area of R. Remember, on something like this one, where especially in the calculator section, it's very tempting just to put it in the calculator and write the answer down. You do need to go and write the definite integral down. So you need to write down, on this particular one, you would need to write down something along the lines of that it is, that for part A, that it's going to be 1/2 times the integral. They tell us the limits of integration from 0 to pi over 2 of that function. So you could write down they will take, if you just write down f of theta d theta, or if you also wrote down instead of that, if you remember that thing squared, don't forget that. Or you could write down 1/2 times the integral from 0 to pi over 2 times the 1 plus sine theta cosine 2 theta, and then that thing squared d theta. So you could do it that way as well. Either one works. It is up to you how you progress with that, but both of those are allowable. And then you could just put that into your calculator and get the answer. For part B is an interesting one too, because of the fact that they're not asking you to actually find out what K is. If you notice here, what they're saying is that you are to write, but do not solve, an equation involving one or more integrals whose solution gives the value of K. Okay, so you have a lot of different options here. You have some flexibility. There's a lot, you can come up with a lot of, just different equations. So it is something that for you to go and work with. Then for part C on this one, distance between the polar points, between the points with polar coordinates f of theta theta and g of theta theta. Write an expression w of theta and then they want you to find the average value. So w of theta, remember on that, is the distance, represents the distance between the two curves at any value of theta. And then they want you to find the average value of that. And then the last one there, find an equation using that equation in part C. Find the value of theta for which w of theta equals that average value. Okay, and in these cases right here, this question right here, except for part B, each one of those would be something you'd want to be making sure to do with your calculator. Now let's look at question 3. Question 3 would be an AB question as well. This would be a question that would be common on both the BC and the AB exam. This would be for this non-calculator section. Now, in this particular problem, they want you're given, the one thing you have to be aware of is what you are actually told. So in this case, what you actually have on this is the graph of f prime, okay? Now, they want you to find a function f that's on that closed interval that satisfies the condition that f of -2 is equal to 7. Now, please remember on this, they're not asking you to go and set up this as a piecewise function and then going through and working with those pieces in particular. But what they want you to do on this one is use the fact that f is differentiable, and therefore we know in this case that f of x is going to be some constant plus a definite integral of f prime of x. Now, it's your job to go through and determine the constants and the two limits of integration. Hint, one of those, maybe that one, is going to be x in this case. And what you want to do in this for this problem is use the fact that f of negative 2 is equal to 7 to help you identify the other piece of information. That is a very common type thing to do on the AP exam. As those of you who took the AP exam last year probably remember, that they will give you something like this and they will expect you to go and get f of x equal to something along those lines. And then you're going to want to go through. The other thing you're going to want to do is calculate areas of the different regions. Okay, now how you calculate those, I would go through on these. I would just use positive values in each case. I wouldn't get in the habit of putting saying, oh, this area is below, so this is a negative, that's above positive, that's above positive. I'd have positive values because remember, the direction you're going does make a difference. If I am going from left to right, this area here would end up being a negative. The definite integral involving that would end up being a change of negative 2 pi, be decreased by 2 pi. But if I'm going from right to left, when you're below the x-axis, that's when it would be positive. And when you're above the x-axis, that's when you would use a negative. So keep those in mind. Be aware of those. Next one is on the interval, when f is, on what intervals is f increasing? Justify your answer. Remember, you got to remember here, this is the graph of f prime, and remember what it means for the derivative when the function is increasing. The absolute minimum value of f on the closed interval. Because it's a closed interval, please remember, you do need to check the endpoints. So in this case, you're going to have to identify all the critical values. Every value where f prime is 0 or undefined on that interval, and also check the endpoints, and then you're just going to want to evaluate the function at each one of those. And then for the last one, for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it doesn't exist. Okay, so in this situation right here, you have to go through and you have this. Remember, this is the second derivative, so it's going to be the derivative of this graph. So use that information, try to determine what the value is, or if it's undefined, explain why it's undefined. Okay, make sure you have those explanations, because a lot of times if you don't include the explanation, like in this case right there, if you don't include the explanation, even though you identified what's going on, they're not going to give you that point. Okay, so make sure you do include that explanation. Now we get to question number 4, and again, this is a non-calculator question. This would be another question that is common between the AB and the BC exam. So in this case right here, what you're given is that you have a function h, which represents the internal temperature of a potato, and it will satisfy this differential equation right here. dH dt equals negative 1/4 times h minus 27, where h is measured in degrees Celsius, and again, h of 0 is 91. So that initial value is going to be a key part of this. Now, what they're going to ask you to do at different points on this one is they're going to ask you to do work with different values of this. In this case, what they have, the first one they want you to do is write an equation for a tangent line when t equals 0. Okay, so keep that in mind, that t is equal to 0, and then they want you to use that approximation to estimate the internal temperature when t equals 3. So t is in minutes, so basically what you're going to do is you got to remember t is 0, so hint that initial value here is going to come into play with this one. So keep that in mind as well. The second part, you do have to take the second derivative here, so you're taking the second derivative of that. Again, please don't forget the chain rule. The chain rule on this one is going to go through and make a difference on that. And then you have to also include here, they want you to find that second derivative and then use it to go and tell me if this is an underestimate or overestimate, and make sure, again, you have your reason, okay? So you're looking at that, at the value, determine what is happening on that thing in terms of if you have that overestimate or underestimate. Think about what the derivative is telling you at zero, and then think about what's happening there, okay? Next thing you have here for part C, you're going through, in this case, they say, here is this alternate model. This is an alternate model, and you're still subject to the same initial condition, that G of 0 is 91. They want you to actually find the expression for G. So what you're going to have to do on this one, you've got to take this thing, and you have to solve it for G. And then give me using that initial condition, determine all constants, and then have a function there. So make sure you go through and solve it, okay? Also, remember, probably the biggest mistake that can happen on this one is when people solve this one, forgetting that constant of integration. If you forget the constant of integration, in terms of doing the solving on this one, if you've set it up right, and you're solving it correctly, if you forget the constant of integration, the maximum on this one was 2 points out of 5. You got 5 points out of the 9 for this one part. So please be careful with that. And when you look for it, when you're solving these things, please remember that constant of integration. Now we're on number 5. Number 5, you're given a function. This is a BC question. Okay, and it's BC because of what's happening in D, C and D, because of the fact that though you have those particular the improper integral and then a sequence series. It could have been BC even without that, because notice what they did in part C is really they took this expression and they used a partial fraction decomposition, and they actually gave you that partial fraction decomposition instead of you having to go and locate it. Okay, and you having to do those calculations. So in this case, the first part is pretty self-explanatory. Find the slope of the tangent line to the graph of f. There's f, find the derivative. Part B, find the x-coordinate of each critical point on the interval from 1 to 2.5. Classify the critical point locations as relative mins, relative max, or neither. Justify your answer. Now remember on this one here, when you do the justification on something like that, you do want to tell them that you want to explain to them how you're going to tell me that you have a relative max or relative min. You cannot on the AP exam, you can't even sit there and say, even if you sit there and say, oh, this is f prime of x, and you have a and b. If you say positive, negative, positive, you can't sit there and say, oh, because of this, it's decreasing from A to B. You have to go through and explain that, that we have a relative min at B because it went from decreasing to increasing. You have to actually say that. You have to actually put that out there. A sign chart like that is not counted for justification. That's been the way it's been for a while. I don't know totally why they are so adamant that you can't use that. I think it might be because of the fact that it's just they want you to express that answer, express your reason. In this case right here, when you go through and do this for part C, remember on that to integrate these, and I think you probably already have an idea what's going to happen with the integral, and then think about you're going to want to simplify your antiderivative before you do your definite integral. So I would go through and do that. And then the last one right here, determine whether the series converges or diverges. State the condition of the test used for determining convergence or divergence. All right, so basically what's going to happen on this one is that you are going to go through, you're going to have to tell me it converges or diverges and explain why you're saying that. Okay? And tell them what test you're using. This one right here, there's a lot, you have some flexibility. There is a hint that I will give you. Think about C. Sometimes something like this one right here, this can be done real quick because just based on a previous answer. So if you think about C, that might give you an idea on where you could have gone for part D. Now let's take a look at question number 6. In this case on here, you're told that f has these derivatives up here in these orders. So you have f of 0 is 0, f prime of 0 is 1. And then every next derivative of 0 is going to be negative n times whatever the previous derivative was. So from this information up here, using that, I know I can say that f prime of 2, or f double prime, sorry, of 0 is going to be negative 1 times 1, which will be negative 1. And then f triple prime of 0 is going to be negative 2 times negative 1, which will be positive 2, etc. Okay? So use that. That's the idea that's happening with this particular definition that they gave you. So they want you to show that the first 4 non-zero terms of this is going to be this expression. It's really going through, you're writing the Maclaurin series, or Maclaurin polynomial for with 4 terms. Okay, so you want to make sure that you do have the 4 terms. Keep in mind that it's not, this one, it doesn't make that much of a difference, but sometimes some people will go through and they interpret the number of terms to be the degree that they want. Not always the case, okay? Like, for example, if we wanted you to write the first 4 terms of the sign of a polynomial that would represent sine, you wouldn't go through, you wouldn't stop at it wouldn't be a 4th degree, okay? So you'd have to go through and make sure you indicate every possible degree that or every term that you have and the required number of terms. The next one, determine whether the Maclaurin series described in part A converges absolutely or conditionally or diverges at 1. Explain your reasoning. Again, go through on that one. You can, once you get this set up, you're able to go through and see a pattern that you can use to write it as a summation in summation notation, and then you take that and look at what they're giving you and determine whether or not that series is going to converge absolutely or conditionally or diverge. Write the first non-zero terms of the Maclaurin series for g of x, which is the integral of this. So remember on this one, you're taking the integral, make that, integrate that. Remember, you're basically dealing with a power function, so you can know how to integrate those. These are polynomials, just use that fact. And then let p sub n of 1/2 represent the nth degree Taylor polynomial for g about x equals 0. Evaluate at x equals 1/2, where g is the function defined in part C. Use the alternating series bound to show that the error there is going to be less than 1/500. So again, you're going to have to go through, use the whole idea. It's nice because it is an alternating series. It's not dealing with the Taylor's theorem on this one, where you have to go and determine where it's the maximum. Alternating series remainder is easy to do, especially in a non-calculator section. The Taylor theorem, or the Lagrange method for it, as I sometimes describe it here, would be something that you would need, probably would be in a calculator section. So just be aware of that. All right, so this kind of concludes my rough run through of the first 6 questions on the packet that I gave you to work on over break. With that, I hope everybody's had a good time. I will try to make a second video and post that later on today. Anyway, I hope you are having fun, and we'll see you in a couple days.